All right. Hey, when we're done, someone remind me that we're recording because otherwise I'm going to make like a 16-hour video accidentally. Okay, here is the plan for today, ladies and gentlemen. We are going to do one example right here of a problem-solving situation, and then we're going to go to the backside here, and we are going to work through 6 series problems, and these are like the final boss of series. If you can beat these, you have won series. All right. So let's begin right here. This problem is a classic. What do I mean by classic? I mean, I did this one when I was in pre-calculus. My father did this one when he was in pre-calculus. My father's father, I'm not sure if he made it to the 11th grade, but if he did, he definitely did this problem in pre-calculus. And it involves a ball. You're dropping this ball. I'm actually going to demonstrate. People that are listening at home, I apologize that you're not going to be able to see this. So I've got this ball right here. Oh, hello there. Scoot over a pinch. Got this ball, and I'm going to drop it. And when I drop it, is it just going to stay planted on the floor? No, it's going to bounce. But does it bounce all the way back up? No, it bounced part of the way back up. And then from here, it's going to drop again. And it drops. Now it bounced back up, but it's even a little lower. And then it continues, and it continues, and it continues. And the question here is, what if we just let this thing keep bouncing forever? To infinity, how far would the ball travel? So on that note, ladies and gentlemen, grab your paper and let's see. Here's our chair. And here I am on the chair with my big smile and my luscious, long, wavy hair. And I am holding a ball. And here's the ground. What color should the ball be? Red. Here's my mind there, Harry. I feel like I'm feeling Where's Waldo today. All right, now we're talking. So a bouncing ball has dropped from a height of 10 feet. So we're letting go of it. I'm going to ask a question. The answer is 10 feet. So far, how far has the ball traveled? That's correct. Okay. So it dropped 10 feet. And then as we talked about, it's going to come back up, but not quite as high. And we're going to assume this is consistent. So the problem says each time it hits the ground, it bounces 4/5 of its previous height. So if we wanted to figure out what height it rebounds to right here, what would we do there?
10 times 4.
Yeah, so first you're going to go 10 times 4/5. It would help if I typed in a 10 and not a 0. Okay. So that is, it goes back up 8 feet. And since we are multiplying by 4/5 each time, what kind of series is this? Yep. So this is geometric. And the value of r is 4/5. Okay. So it gets back up to 8 feet. And then it drops again. And then it turns around and it comes back up, but not quite as high. One more time, if we wanted to find how high it goes here, we could just go 8 is multiplied by 4/5, and we get 6.4. And my calculator died. So there's 6.4 feet. And I think that's enough calculating. Let's just say that it continues like that forever. It's never going to stop.
Bouncing ball stops bouncing.
Yeah, we're assuming that like eventually it's still going to be going, just like so microscopically that you can't see it. Is this like real world? Not quite. So it's geometric. It's going forever. The first thing you want to do is figure out what's the sum of an infinite number of bounces. Well, remember from last time, folks at home can't see this on the board, but remember we had this formula. If your ratio is smaller than 1, you can use this very simple formula to find the sum of an infinite number. And if the ratio is bigger than or equal to 1, then it diverges and you get infinity. So is our ratio smaller than 1? Okay. Yeah, this is smaller than 1, which means we can apply the formula a1 divided by 1 minus r. What's our a1? 10, right? Initially, it drops 10. And then we're going to divide that by 1 minus 4/5, which is going to give you 50. Now, that's not the answer. I'm telling you right now, that's not how far the ball goes. Can you folks tell me why not? What are we not taking into account here? Ethan's got an idea. Yeah, so what we found that, and then we added the 8 to it, and then the 6.4, and then this. So what this is doing is it's just giving us all of the downs. First down, the second down, the third down, the fourth down. What have we not taken into account? Ups. Okay. So if we wanted to find the total distance that this thing travels, what could you do if you already know the downs to find the ups? So if we double it, that would include all of the ups. Now, Ray, I heard you say minus 10. Why minus 10? Very nicely put. So can you guys see that the ups are going to be 10 fewer than the downs because you never go up 10? So you want to say 2 times this distance and then take away the 10. And the reason you're taking away the 10 is because this right here never ever happened. So that would be what? 90 feet our ball traveled. Okay, so as I mentioned, this problem right here, an absolute classic. Are you going to see this one again? Yeah, well, but probably going to. Yes, that would be. I would give up hope on this one. We're going to keep visiting this guy. All right. So on that note, yes, yeah, it's all in there. I think that's all I want to do with word problems for today. What I would like to see you guys tackle is this last page right here. And this will be it for today's class. Can you handle the final boss of summation? We're going to keep going. So take a look at number 1, everyone. Put your pencil right here. This right here, it says find the 10th partial sum. That means you want to find the sum of the first 10 terms. This is your pattern. Good question. Even before we talk about that, let's talk about this. On these, you need to think about whether they are finite or infinite. If I tell you it's the 10th partial sum and you're adding 10 terms together, don't you know that it is finite? So that's the first thing. Now, Evan says that it is geometric. Do you guys agree? If it's geometric, and you're right, it is, that's because there's some number that we're multiplying by from here to here, here to here, and here to here. What would that number be? I have a vote for 0.8. It is. It's 4/5 or 0.8. It's the same as the last one. Kareem, how did you figure that out?
I just said 50. How do you get to 40? You just divide it times by 0.8.
Okay, I buy that. If you can't, if you don't have the juice like Kareem does there, you can also say, I'm taking this number, I'm dividing by this. That gives us 0.8. All right, so now this one, we know our ratio is 0.8. We also know the formula we're going to use is this guy right here. So the other things we need are the A1 and the number of terms. And those aren't hard to come up with, right? A1 is 50 and N is 10. So the formula we're going to use is that the sum of the first 10 terms. So here's 4 of them right here. There'll be 6 more. If you were to add all those together, you get 50 multiplied by 1 minus 0.8 to the 10th power, all divided by 1 minus 0.8. Now, how would you guys feel, since I think this is the easy part, putting it in the calculator, how would you guys feel if I just gave you the numbers today? So this one comes out to be 223.156. And keep that number in the back of your pocket because it's going to be important in about 45 seconds. Look at the next one. Everyone, put your pencil on number 2. What's the only difference about this one compared to number 1? Yeah. So this one is infinite. It's still geometric. And our ratio is still 0.8 because it's the exact same series. All right. So now what you're going to do is you're going to say, if it's infinite, I need to check the size of the ratio. Is the ratio smaller than 1? Yes. Okay. And that means that if we were to add up the infinite number of terms in this sequence, keep in mind, you can't actually add up an infinite number of things. This is just saying, as you were adding them up, what number would you be approaching? What number would you be getting close to? It would be 50, so there's A1, divided by 1 minus 0.8. You don't have to memorize this formula, but notice that it's always just the same thing you had up here. Cover up the parentheses. Y'all see that? So that would be 50 divided by 0.2. Let's just suppose that in the heat of the battle, you goofed right here and you came up with an answer that was 200. 200 is not correct. How could you use this right here to know that 200 is like wrong? Yeah. So we know our number has to be bigger than this. And in fact, if you took 50 and you divided it by 0.2, you would get 250. Let's keep rocking. Let's keep rolling. Let's give number 3 a try. Boom, 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 boom. Right here it says find the 100th partial sum. Simon, if it's 100th partial sum, is this thing going to be finite or infinite? Okay. So we know it's finite. And then the next part is we want to figure out, is this arithmetic or geometric? I have a vote for arithmetic. That is correct. If it's arithmetic, there has to be a common difference. 7. Is it positive 7 or negative 7? So our common difference right here is 7. All right. So if it's a partial sum and it's arithmetic, we know we want to use this formula right here, right? Boom, 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 boom. So we need 3 pieces of information. We need n, we need a1, we need that should say an. Harry, give me a hand. Do we know any of those?
A1's 53.
I agree. That is 53. Ooh, that rhymed. Harry, do we know any others of those?
N is 100.
Yeah, because it said 100th partial sum means you're adding up the first 100 terms. The thing we don't have is the nth term. Now you got 2 options. There's the brutal option. You can just keep adding 7 over and over again until you got 100 terms. Option number 2, plug it in. Now what are we going to plug it into?
Arithmetic series.
Yeah, we're going to say, I know that the nth term is equal to 53 plus 7 times n minus 1. Right, that would be the arithmetic sequence formula right there. So we can plug 100 into that. 6
746.
746. Nice. Okay. So once again, that's the hard part. Once you got that, you are golden. Our sum would be equal to 100 divided by 2, multiplied by the sum of 53 and 746, which is going to give you 39,950. Woo. Okay, 3 down, 3 to go. We have almost defeated the final boss. Let's go to number 4. Simon, I'm coming back to you. Number 4, is this thing going to be infinite or finite?
It's finite.
Why is it finite?
It gives you a value.
Because it what?
It gives you a value at the end, -45.
So it's starting here, it's stopping here. If it stops, it's finite. I like it. Okay. Next question, gang. Is this thing going to be arithmetic or geometric? Vote for arithmetic. That is correct. If it's arithmetic, we need a common difference. What's that common difference going to be? Yeah. See how it's going down by 5 every time. Down 5, down 5. So we need the same 3 pieces of information that we did on the last one. Hey, Ray, do we know any of this stuff right now?
A1 is 30 and AN is number 45.
Okay. So that means we're going to have to work for it a little bit to get the number of terms. So this is kind of like the last problem. You want to start by saying, I know that the nth term is equal to the first term. Take away 5 times n minus 1. And then boom, 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 boom. We want the last term, so what are we going to plug in right here, everybody? Got it. -45 goes right here. And you solve that equation. Hey, if you solve this equation and you get something like 6.4, how do you know you're wrong?
So it's the number of terms. It can't be 6.
Yeah, it's got to be 10, 11, 12. It's got to be a whole number. If you solve that equation, I think you're going to come up with 16, is it? All right. Questions how we got to here? Anything we're wondering about? Okay, then once again, that's the hard part. Easy part is just throwing it into this formula. And so I'm just going to tell you what that gives you. That's going to come out to give you -120. Okay. Negative makes sense because you can see a lot of the terms are going to be negative. Okay. Questions on the fourth one? If not, here's the last 2. Notice that they are identical except for that this one is finite. It stops here, and this one is infinite. So, are they arithmetic or are they geometric? We vote for geometric. That's correct. Okay, if they're geometric, we need the ratio. What are we multiplying 4 by to get to 6? Mm-hmm. And if you weren't sure how to get it, you can always just do 6 divided by 4, which is going to give you 1.5. So for both of these, r is equal to 1.5. Now let's do the quick one first. Which one's the quick one? Right here, number 6. This one is going to take us about 20 seconds. Because look at the ratio. Does everyone see that that ratio is bigger than 1? That means that this series is just going to get bigger and bigger and bigger and bigger and bigger. It's going to diverge, which means that it gets infinitely large. And for your answer, you know what you get to write? Infinity. Okay, so don't try to use any formula on this one. It just diverges. Infinity is your answer. Done. Which means our last problem for today is number 5. We've got the ratio, we need the number of terms, and we need the first term. I know the first term is 4. The number of terms we're going to have to work for a little bit. A little help here. How do we come up with the first, or with the number of terms? How are we going to get that? Yeah. So we know that the sequence formula looks like this. And we want the last term, which is this guy. I'm going to grab another calculator, which is hopefully working. Yeah, there we go. So you're going to put 2187 over 32 on this side. There was a problem kind of like this on today's quiz. You guys know that you want to get this by itself first, which means you want to start by dividing by 4. So I'm going to divide by 4 over here. I'm going to divide by 4 over here. In your calculator, if you want to, you can just put it in this way. 2187 divided by 32, and then divide again by 4. And you're going to get a decimal. Just remember that decimal, 17.08, blah, blah, blah. So we're to here. I noticed that some of us had a hard time with this on the quiz. What do you have to do to both sides if you want to get the thing that's in the exponent of the parentheses? Yeah, so you can take a log. It's going to have a base of 1.5. Harry, is this the pencil that I won from you?
I think so.
Because it's broken.
Well, you handed it to me first.
What was that?
You gave it to me first. It was
Are you saying that I gave you a broken pencil and then you gave me back a broken pencil? When you put this in your calculator, alpha window, log base 1.5, and then you want to take this entire number and copy it right here. And you got to get a whole number. Did I get a whole number?
Yes.
Ooh, yes, I got a whole number. So 7 is equal to n minus 1, which means n is equal to 8. Last step, I've kind of used up all my room here, so I'll squeeze it in over here. Now you can say the sum of the terms is going to be 4, our first term, times 1 minus 1.5 to the 8th power, all divided by 1 minus 1.5. And when you do that, you're going to get this number, 197.03125. So there it is, ladies and gentlemen. If you can do those, if you can do all 6 of those problems, you have beat the final boss for series. And we are actually done with sequences and series. Turn to your neighbor. Say nice job.
So we can finish problem set 4 now.
You can now do all of problem set 4, yeah.
So not